very good morning, a very good afternoon, and good evening based on wherever you're joining. My name is Dhrubesh, and today I'm gonna give a talk on magic with Babel Macros. So before we dig into the topic, I want to also talk about why this topic, right? So I think Babel Macros was introduced back in 2017, 2018, and it seemed to be a really fascinating thing because of the things you can do just by that, right? A lot of pattern emerged because of that, and yeah, but nowadays not a lot of folks talk about it. So I thought, why not give it a shot and see if you folks are interested. So the aim of this talk is to give you an introduction about Babel macros so that you can go ahead and write your own plugin perhaps or build your own macros. Yeah. So my name is Dhrubesh. I'm from India. I work at a startup called Organize. I majorly handle the front end side of things. We are also actively hiring. If anyone is looking out, please reach out to me. I also run a YouTube channel called the Junior Developer, and I host a podcast in that called the Junior Developer Podcast. If you are interested in front-end technologies or tech in general, or maybe if you're interested in how to have an impactful development career, you should perhaps check out the channel and you might find some of the videos quite interesting. Also on Twitter, you can find me as the underscore junior underscore dev. So that's essentially my introduction. Let's get to the talk. So AST, right? AST is an amazing thing. It stands for Abstract Syntax Tree. It's an amazing thing, and I feel that every developer should essentially learn about it because it's essentially one of the building blocks of the transpilers which use your plugins to transpile your code, right? And without knowing it, you might not be able to understand how your code is being transpiled. So when I heard about this term AST, right, I got really curious and I, of course, boost up my laptop and tried Googling what is an AST, and the first link was of Wikipedia. And this was the definition which was thrown at me. It says in computer science, an abstract syntax tree or just syntax tree is a tree representation of the abstract syntactic structure of text written in a formal language. So this did not really this was a pretty complex definition for me, and it did not really hit me what exactly AST is. And as we know, a lot of folks who are into coding don't necessarily are from the computer science background, so to them this does not really make sense. So I tried to find a better definition which is much simpler in understanding, and I stumble upon this definition. It says an abstract syntax tree or AST is a tree representation of the source code of a computer program that conveys the structure of source code. So what it means by that is essentially you can look at the AST and you can derive what code you're writing. But I mean, it's of course not as readable as the human code which we write, but it's the representation is purely for machine to understand how exactly the code is structured, and you can get almost, yeah, you can get everything about the code just by looking at the AST. That is one point. The second point is all the transpilers actually use this, and based on the AST they transpile the code, and we are also gonna try out some of those transformation here live to figure out how exactly it looks. So yeah, I mean, let's explore AST. As Drake says that reading about AST, the theoretical definition of something might not purely make sense, but when we go ahead and explore AST, that's when it start making sense to us, right? So you can go to this link called the AST Explorer, and let's write some dummy code here. I don't know. So my talk is on magic with Babel Macros. And since we have a let here, maybe we should also define a const to figure out how different does it look in AST. So we can just do, sorry, uh, get speaker name, and we can have one argument as talk name, and we can just do if talk name equal to Dhrubesh talk. Then we will also figure out how if statement works out in AST. Then I can just return my name, and else I can just go ahead and return null. So yeah, now that we have this, I can just do speaker name. I can do get speaker name, and I can pass this. So as you can see, as I'm typing it out, right, the right-hand side of things is being populated. So that's how we know. So for example, right now in here, we have 4 variable. I think let's get rid of this. This is of no use to us. So we have 3 variable declarations in here. So we have, of course, the const, we have let, and we also have got an arrow function. We have this function is returning something, once a string and sometimes a null. And we have got an if statement where we are comparing the left-hand side and the right-hand side, right? So let's kind of go ahead and explore each of the variable declaration to see how it looks. So if you go with the first one, you can see the information available is the start and the end of this particular piece of code. And then inside declarations, it has got to start from 4 to 44, I'm assuming, from here to here. Yeah. And yeah. And inside this, we have an init block, which talks about with what value it was initialized. And you can see the kind as let in here, right? So I can also go and do something of this sort, React Advanced, space. And then if you see, this becomes an expression statement because it's not necessarily a variable declaration, right? Variable declaration is when init is being populated. Init is basically this part of things which we saw here. Expression statement is you're trying to update something, right? And it has got an operator. Equal to is the operator. And we have got the left side of things, which should be the variable name, and right side of things, which is what do we want to, basically the value of it, right? Likewise, if we go ahead and explore the second variable declaration, let me just close this one. Yeah, we can just explore this, and it has also got something similar, but as you can see, the kind here is const, and the kind here was let, and we can just go ahead and check the arrow inside the init function. It explicitly mentions that it's an arrow function. Let's see how it looks if it's a normal function. So I can just quickly convert this to a normal function. And yeah, boom. So this is a normal function. Yeah, there's a normal function. So in this, if you say it purely says function declaration. So it does not talk about what you call arrow function. It does not mention that. It purely says function declaration. And inside the body, we have the block statement. In fact, we can explore that. Let me quickly remove this. Um, Inside here, we can quickly see inside the body of the arrow function, we can see it has a block statement. And in block statement, we have got an if statement specifically, and we have got a return statement, right? Let's explore the if statement first. Inside the if statement, we can see the consequent. It's also a block statement with another return type altogether. This will essentially be the string which I'm returning here. And inside if statement, inside the test, we can see the identifier here, right? Just like how we saw in this particular case, in that the identifier was 1 equal to. In this case, we have triple equal to. The left-hand side would be the talk name. So talk name, it's not the value, right? It's the variable name. And that is the reason it says name here. And on the right-hand side of things, we can see the, again, another variable with which we are trying to, compare. And here you can see, as mentioned earlier, the type as const. And inside this, it's one and the same thing, but it's a call expression. Call expression comes in when it seems that you're trying to call a particular function. And it also talks about the argument. And inside the argument also, it's giving the name, because this variable is pointing to this string. We are not directly passing this string, right? So, and inside the calling, whatever the name of the function we are trying to call. So this is how an AST looks like. And as I mentioned earlier, right, just by looking at the AST structure, you can derive the code. But of course, it will take a lot of time to do that, because this is more human readable than the AST itself. So this is not just the only representation of AST. You can also try out the JSON part, which throws in everything at once. This was the tree representation. And we also have something called as join.js. Let me just copy paste this. And I can just do show AST, and it will showcase everything you need to know. And this is also a good representation. It gives you a verbose explanation of what all nodes you have, what all tokens you have. It lists down the keywords, identifiers, punctuators, and everything you need, basically. I can just go to the PNG version of it. And this is also another tree structure, but I feel that this is a bit verbose and it's more human readable, because it has got everything. You can just read it through and understand just by looking at it. So that's what AST is. Let's talk a bit about Babel now. Babel started out as a transpiler, but I mean, it lets you write the updated version of whatever ECMAScript specification is, even to the browsers where that particular updated expressions or whatever those things are not supported. You can do that using Babel, but it ended up becoming, more something more than that. And in fact, we can quickly take a look and take a look at how we can transform something in Babel live in action. So yeah, so you can still go to AST Explorer, and I can just select the Babel parser here, and let me just close this out. I can copy paste. Oops. Yeah, I can copy paste this here, and this again the AST which we explored earlier. And I can, so we can try out one thing, which is we can try out to reverse the variable name so that it after transformation. So this is where the transformation is located. This is the code which we wrote, and this is where you can write all the specifications which you want to. And this is the tree version side of things. I mean the tree ASC output. So inside the identifier, I can quickly console log path, and I can perhaps increase. And inside the node path, we have got a node, and we have got the name, we have got the LOC location, the end position, the start position. File name is not populated for obvious reasons. We got the identifier name as well. I believe this is pointing to this. So if we are trying to update the name here, then I think we can do something of this sort equal to node dot path dot name. We can split it. We can reverse this, and we can just go ahead and join this. Oops, it will be path.node. Yeah. So now I think you can see here, this is supposed to be Dhrubesh talk. This is supposed to be get speaker name, and etc. etc. So this is how the transformation plays out. Let's talk a bit about Babel macros, right? So Babel macros are essentially it's a way to apply code transformation without having to install a lot of plugging in each transformation. And the best thing is it's supported across CRA, Gatsby, Next.js, and almost all the other React-based frameworks. So why Babel macros, right? The issue with regular Babel plugins is, of course, it's great, but it has got few downsides. For example, it might be difficult for users to set it up and configure, especially when in tools like CRA or Gatsby. Of course, also you might end up getting into a conflict or in a scenario where you're having to debug certain things because of the way it's. I mean, when we set up plugins, right, the order of plugins matter a lot. So you have to, if you mess up the order, it's really difficult to debug it as per se. So we use something called as Babel plugin macros for to write this, and Babel plugin macros in itself is a plugin. I think we can explore a few of them. One of this, which is one of my favorite, I like it, which is a track translation. You can just put in the string here, and it gets transformed to whatever the value is. I believe this is high in Vietnamese. And we also have CSS to React Native macros. Here you can write normal CSS. It will get converted to React Native style sheets. The output will be this sort. And folks from Angular background, if you're missing NGF, you can try to figure out, you can try exploring this as well, where TJF becomes this sort. But there are a few caveats which one needs to keep in mind. One is macros are synchronous. So if you're trying to write one, right, you have to make sure that it runs in the node environment or whatever machine the macro is being run at. And macros are evaluated at compile time as well. So you also have to keep that in mind while building one. So yeah, I think that's all the time I have today, folks. Thanks for listening to my talk. We've got a lot of talks lined up today at React Advanced, so stay tight. And thanks a lot for listening to me. Have a great day.